What exactly is testing? Well, we're writing our code, obviously. That is what we did throughout this course. And we manually tested this code. With that, I mean we simply visited the page, we sent requests to our API. Now, the big advantage of this approach is, of course, that we can see our page. We can really see the page as our users will see them. We can interact with our API as any developer would interact with it. And therefore, manual testing is super important. But there also is a downside. It's easy to forget to test something. It's easy to only test some parts. And especially when you make changes to your code, it's easy to break something in some place of your app which you might not think you're breaking, and you're not testing it explicitly, and therefore you introduce a bug which you only find later or maybe never at all. That, of course, is the downside. And it's pretty hard to test every possible feature and every possible combination of steps in your application after every tiny change you make. And that is where automated testing comes into play. Automated code testing means that we write code that tests our code. So we define steps that are executed, we define certain scenarios that are tested, and we automatically run these tests on every change or after every important change we made. So we can run them whenever we want. We can even put them into our deployment process and run them right before our app gets deployed. And that will throw an error at us whenever some of our tests fail, and we can then look into these tests and find out why they failed and fix them. The big advantage of automated testing, therefore, of course, is that we can cover all core features and we can define all possible scenarios we want to test, and therefore really make sure that we don't introduce breaking changes. But of course, there are downsides to automated testing too. If you write the wrong tests, then you might have a good feeling because all your tests are passing, but maybe you're just testing for the wrong things, for the wrong scenarios. Additionally, well, you only test what you define, and it's also hard to test the user interface. So you might not really see what your users see. So it's a combination of both manual testing, which we did throughout the course and which you naturally do, and automated testing, what you'll learn about in this module. It's clear again. Testing, so and with that I mean automated tests, allows us to automatically test everything, and there's a star behind that because we only test what we define, so only the tests we write. But in theory, it allows you to test everything in your application after every code adjustment, after every code change. Therefore, it's easy to detect breaking changes, even in places you might not have expected to break upon your latest change. And with automated tests, we ensure that we have predictable, clearly defined testing steps. Our tests obviously always run in the exact same way since we define all the steps in code. And that, of course, ensures that we can rely on the scenario always being the same. If you're manually testing your app, you might think you're doing the same thing as you did the last time, but in reality, you might not be doing that because you forgot a step. So that is why you should test. How do you then set up your Node project for testing? No matter what you're building with Node.js, so no matter if you're building a page where you render views on the server, if you're building a REST API, or if you're building a GraphQL API, you want to run tests automatically. So you want to run code that tests your code. And for that, you typically need a couple of tools. You need a tool that executes your test code. Sounds pretty simple, but you need that. And it should not only execute your code, it should also give you a nice output that tells you whether your tests all passed or if a test failed. So that is the first tool we need. The second tool then is one that does not just run our code, but that also allows us to define certain conditions that have to be met. So we want to assert certain results. We want to find out if certain scenarios succeeded, if tests succeeded. We want to define what success means in a certain test. So we want to validate the test outcome.
Now, for running the tests, there are different tools for all these steps, but for running these tests, one popular framework is Mocha, and we'll use Mocha in this module here too. And for asserting the results and defining conditions, Chai is a popular choice, and we'll use that in this module too. There are alternatives like Jest, but Mocha and Chai are really popular, exist for a long time. There are a lot of tutorials out there for you to dive deeper, and therefore I will also use them here. You're certainly not doing anything wrong when sticking to these tools. Now, as you will see throughout this module, there will also be one other tool we need when it comes to managing side effects or working with external dependencies or certain complex scenarios. There we'll use Sinon, which is a tool that allows us to create stubs or mocks, and I will come back to what that is later. Now, with that all out of the way, I'd say let's install our basic testing tools and let's set up our testing environment and then also write our first test so that we can gradually walk through our Node application and see how we could test it. Now, to demonstrate testing, I picked a snapshot from our course where we just finished the REST API with async await, because that is particularly nice to test and to dive into testing. Now, obviously, testing different kinds of Node applications like a GraphQL API all have their own specialties and special complexities, and this is only an introductory module here. If you want to learn all about that, you find dedicated tutorials for all these different scenarios. That would be enough content for its own course, and therefore I rather did not squeeze it all into this one to not bloat it. But what you learn here, the core ideas, the core concepts, the way of thinking about testing, and the general setup, that will always be the same no matter which Node application you're building, and therefore this is the super important start into testing that you need to then really master testing. So here I have this snapshot, and you find that code attached to this lecture, of course. And to add tests here, we first of all have to set up our testing environment with Mocha and Chai. Now, you can simply Google for Mocha.js to find mocha.js.org, where you can find the official docs and find out how to install it, how to write tests, and so on. And the same, of course, is true for Chai. You can Google for Chai.js, and you can learn more about Chai here and find out how that works. But of course, I'm going to walk you through all these fundamentals here. So let's install these things here now with npm install --save-dev here in our project. And there it's just Mocha and Chai. These are the two tools we need to get started. So let's install them here and let's wait for that to finish. And with the installation process finished, let's start writing our first tests. Now, for that, first of all, let's go to the package.json file and there to the scripts section. And there you should have a test script already. If you don't, simply add it. Now, by default, this does not have a useful command in there, so let's get rid of that. And here you can now just run Mocha. Just like this, just type Mocha, this dependency you just installed without any other configuration. Now, what you can do now is you can run npm test here in your terminal, navigate it into the project folder, and this will now run all your tests you defined in this project. But of course here it's going to complain that it didn't find any test files. The reason for that is that Mocha by default looks for a folder named test. So let's add one, and it has to be named test, not tests, not anything else, just test. And in there you can now define files that hold your testing code. Now, let's start very simple, and I'll name it start.js. You can name it whatever you want. Doesn't have to be named start, can be any file name you want. Should be a JavaScript file, though. Now, in here, we write our testing code. And writing testing code can be strange when you see it for the first time, but it quickly becomes very straightforward. You simply write a test by writing it, just it. And it is a function provided by Mocha. Now, it might look like a strange function name, but the idea here is that you give your tests name and they read like plain English sentences. because indeed it takes two arguments, and the first one is a string which simply describes your test. And this is something which you'll later see as an output for your test, which will help you identify which tests failed and which tests succeeded. So obviously this should be a title that kind of describes what's happening in the test. So here we could, for example, test that two numbers are added correctly. Now, of course, this is kind of a stupid test here. It will become more useful later, but this is just to introduce you to testing. So here it should add numbers correctly. Could be a description, and you see this now reads like an English sentence. It should add numbers correctly. Theoretically, you can of course put any title you want in here, but it's a convention to write sentences like this. The more important part, of course, is the second argument, and this should be a function that now defines your actual test code. Now later we'll dare reach out to our own models, our own controllers, and test these, because that of course is the idea, that we test our controller functions and so on. But for now we will write a very simple test here. We'll add a num1, which maybe is 2, and a num2, which could be 3. And now we want to test if these two added together are 5. And yes, this is an absolutely stupid test. Of course they are. It's just to show you how to run your test. It'll become more helpful later. So we get num1, we get num2, and now we want to check if they are added up to 5. And of course, later you might have dynamic values that the user enters and that you transform in your code, and you want to test if your code transformation works correctly, and then this makes a lot more sense than if you have strongly typed values like you have here. So how can we now check if our test succeeded? How can we now define a success condition? Well, that happens with the help of Chai. Mocha is responsible for running our tests and for giving us this it function that defines where we define our test code. Chai is responsible for defining our success conditions. And for this, we just need to import something from Chai here. We import a function that is named expect. You do this by requiring Chai and there the expect function. Now there also is a different way of defining our conditions with a should keyword, but we will use the expect way. You can learn about the should way here in the official docs. In the end, they do exactly the same. They allow you to define success conditions. It just differs regarding how you write your test conditions. And I like that expect style more, but you can definitely dive into both. So how does this now work? Well, you write expect, and then inside of this function call, so as an argument, you pass your code that you want to test or your result that you want to test. Like here, num1 plus num2. So we expect this addition here. Now, how can we define what this should be? Well, again, this is close to defining or to writing normal English sentences. Chai gives you a couple of properties on this object, expect returns. So expect returns an object. And there you have properties like 2. And then on 2, you have another object which gives you things like 2 equal, and then equal is a function where you can define the value you expect this to equal. So this really is something you have to get used to, but in the end you again write an English sentence with the help of all these helper properties and methods. And of course in the official Chai docs you'll learn about this too, and there you also learn about all properties you have available. So if you dive into the guide here or into the API docs, well then of course you can learn all about expecting, and you can see what you can change so that you can say to equal, to be, or whatever you want. So here we expect num1 plus num1 plus num2 to equal 5. Now with this defined in the start.js file in the test folder, if we run npm test again, it will automatically look for that test folder and execute all tests in all files defined in that test folder. And therefore here in the output we see a check mark next to should add numbers correctly, which of course is this test, which is now executed correctly, as you can see. And that is what you want to see when writing tests. You want to see that all your tests pass. It's because now, of course, we could define more than one test. For example, it should not give a result of 6 or whatever you want to name it. And now here we could say we expect num1 plus num2 not to equal 6, for example. So now we're basically checking whether this is not only 5, but it's also not 6. So now we have a second test defined. And now if we rerun npm test here, well, then we get 2 passing tests. And now, of course, it's easy to make a test fail if I, for example, change num1 here to 3, and I now run this again. Now you see I have a failing test, and you see I get an error. I get that it expected 6 to not equal 6, because 3 plus 3 now is 6, but we're not expecting this to be 6. And this is therefore hinting us at the test that failed, giving us a reason of why it failed. And therefore, when we're not testing dummy code like this, where we have the reason for the fail written in the test, but where it might be in our other code, which we eventually will test, then this will allow us to fix our other code. Of course, it's now important to point out that these tests are totally redundant. We're not testing our code, not our application code at least. We're testing some dummy code, and we're defining everything our test relies on directly in the test. Therefore, this test runs standalone, totally detached from our application, and whether the test succeeds or fails, it only depends on the testing code itself, which of course is a test you should omit. It's not a helpful test. This is just some JavaScript code you're running. Nice if you have too much time to spend, but certainly not helpful. In reality, you want to test your application code, and you want to test code that's not entirely defined here in your tests. Instead, in your tests, you typically only define your success condition. You can, by the way, also have multiple success conditions, multiple expectations. And you might define any additional setup you need for that test. For example, user input you're assuming for this test to simulate different scenarios. But you don't want to have the actual code or the actual behavior you're testing in your test. That is not the idea. And therefore, let's get rid of these dummy tests here. I'll simply comment them out. And let's write a more realistic, a more helpful test. Now, what could that be? Let's have a look at our middleware, at our is-of middleware, and let's maybe test something related to this function we're exporting here. We're exporting a middleware function, and in the end, we could test all kinds of things there. So let's add a new file in the test folder, the of middleware.js file, for example, and you can name this whatever you want, of course. And here, I now want to import this function and then test it. So I'll import my of middleware by requiring it, of course, from the middleware folder, from the is-of file. And then again, we define a test. Now, what could we test here? There's a bunch of stuff we can test, and we will test different things here. But the first simple test could be that we want to make sure that we really get an error whenever this here does not have an authorization header. So back in the of middleware.js file where we define a test, we could define a test where we say it should throw an error if no authorization header is present. This is a valid description for our test here. And then I'll add a function where we actually add our testing code. And now we, of course, want to call our of middleware manual here because we're not simulating a full request flow. We're not simulating a click of the user, which then sends a request, which then triggers the middleware. We just want to test our middleware function. This is called a unit test, by the way. We test one unit of our application. In this case, that is this function. Typically, a unit is a function. Here, it's this middleware function. An integration test would be where we test a more complete flow. So where we maybe test whether the request is routed correctly, and then also the middleware, and then also the controller function. But you don't test that too often because it's very complex to test such long chains. There are multiple things that could fail, and by writing unit tests, it's way easier to test different scenarios for each unit. And if all your unit tests succeed, you have a great chance of your overall application working correctly, and therefore writing unit tests is very helpful. If a unit test fails, it's also easy to find out why it failed. If you have a lot of steps involved, it might be harder to find out which step failed. So we're testing this middleware function only, and that of course means that we have to create a dummy request object we pass in. Because normally that's passed in by the Express middleware, just like response and next, but now since we're directly calling our middleware function, we want to define our own request object. And that is actually great because that allows us to define different scenarios. So here I can create a request object, and that object here should have a get function now, because in the auth middleware I'm calling this get function here. And this get function now in reality returns the value of the authorization header. Now in reality, this get method here provided by Express is way more complex, of course. It does not only scan headers, it scans different parts of the incoming request. But our goal now is not to replicate the Express framework, but to test one specific scenario. And here this scenario is that get authorization does not return an authorization header, because that is what we want to test here, that in this case we throw an error. So here this function should simply return null. This means it does not return a value for our authorization call here. Now of course, here we pass an authorization string to the get method. Here I'm not expecting this argument. You could of course add it here. You could expect your header name or whatever you want to call it, but I don't really care about this. I know that the code I want to test calls the get method, and I know that I want to return null to simulate that there is no authorization header. Because I of course know the code I'm testing, and I want to test different scenarios. And this is how you have to think about testing. You're testing different scenarios. You're not trying to rebuild the framework you're using. You're not trying to rebuild some complex functionality. You want to force your code into certain scenarios. You want to test them under certain scenarios. And here the scenario is that the get method on the request object returns null, no matter what it does in reality. So here we return null, which of course could be the case if in our real app that really runs, we get a request where no authorization header is set. In this case, this would also return null or undefined. So here we return null. Now we can call auth middleware and pass in our own request object here, which has nothing else. It has nothing else the request object normally has, but it has everything we need for this test. There we only need this get method, and it has that. Now for the response object, we can pass in an empty dummy object because we're not testing anything related to this response object, and the code we're testing also doesn't rely on it. It doesn't even use the response object in this entire function, and therefore we don't need to spend any time on adding any logic to this response object. And now the next function, which is called at the end, well, we want to pass it in, but we don't care about what it does because we're not really executing a next step here anyways. So here I'll just pass in an empty arrow function so that it is able to call that without throwing an error, but that it also doesn't do anything because it's again not what I want to test. I only want to test the behavior when get returns null. So now we're calling this, but of course we wanted to test something, right? So let's now import expect again by requiring chai and then expect. And now let's expect the result of that auth middleware call here. So of that entire call to be something, or in this case, to throw. That's also just another utility method you have here. You can find this in the official docs, of course. Here, if you scroll down, or if you, as I do here, search for throw, you'll find detailed explanation. So now here I expect this function call for a request that returns null when we try to get something for a given header name. I expect that to throw an error with a message. And now the message, of course, is defined in our real code. we should have a message of not authenticated. So this exact message here. So I expect this to be thrown. Now let's rerun npm test here. And I actually get an error. And that, of course, is strange. Why am I getting the error I'm trying to test for? Actually, this should pass without an error because the function throws an error, because that's what I'm expecting. Well, the reason is simple. I am calling my middleware function here, and this middleware function just happens to throw an error. I don't want to call it myself. I want to let my testing framework. So I want to let Mocha and Chai, these two tools, I want to let these call this function for me so that they can handle the thrown error. Here I would have to handle it myself, and that would defeat the entire purpose of testing this. So instead of calling auth middleware directly ourselves here, we instead only pass a reference to this function here to our expect function, and we only want to bind the arguments we eventually want to pass in when our testing setup calls this function. Bind, first of all, requires an input for the this keyword. That can be this. And then it has the 3 arguments that will actually be passed into the auth middleware function once it gets called. So we're not calling it ourselves here. We're instead passing a prepared reference to our function, you could say. Prepared in the sense of we're defining which functions get passed in or which arguments get passed in. So we're passing that prepared reference to expect. And now if you rerun npm test, you should actually see a passing test. Now, if you're expecting a slightly different error message and you rerun npm test, you actually get a fail here because we expected to throw an error including not authenticated, right? That is what we're expecting here with an exclamation mark, but we got no authenticated with a dot. And that's the idea behind testing. You have to be clear here because you can test for all kinds of different things. And here we're testing for the correct error message being thrown. And therefore, this test only succeeds if we A, have an error, if we're not throwing an error in here, if we're instead sending our own error response and we're not throwing an error, then this test would not succeed. Or if we throw an error with a different error message, as you just saw, this also doesn't exceed. Now, the cool thing is, if we now ever change something about this code, for example, we decide to remove this check here, where we check for the auth header, and I now run my test again, I get an error. And that tells me, oh, I need to do something because my test failed, this test where I want to make sure that not being able to retrieve the header actually throws an error. That does not pass anymore. And therefore, now I should have a look at my middleware and I can find out, oh, I commented this out. Or maybe I never added this functionality in the first place. Or I tweaked it in some way that this error is not thrown anymore. Maybe I also just change this condition. Accidentally, I'm checking for the existence of a header to throw that error because I have a typo or because I needed that in the past or whatever. Then my test fails, as you can see, and I can look into my code and find out why it failed. And here I see I expected it to throw an error, but actually I got a different error. And since I got a different error, well, it's probably something wrong with this code here. And I can look into that code and eventually find out that here I'm missing an exclamation mark, for example. So that's the idea behind testing. Whenever we then change something in our code, as long as we have tests for it, we get a warning, we get a chance of tweaking our code and fixing the issue we introduced. Now that we wrote our first test that actually makes sense, let's continue and write another one. Our code here only works correctly if we have a header, an authorization header, which can be split into 2 pieces because that's what we're doing here. The reason for that, of course, is that we expect something like bearer and then our token, right? That is how we send our tokens. That is how we send that authorization header. And therefore, this is something we could test for. It should throw an error if the authorization header is only 1 string. Now let's pass a function here again where we define our actual testing code. And in there, now again, I will create my own dummy request object where I get my authorization header. Now it's not null anymore, but it's only one string. So only, let's say, XYZ as a token value. And that means that now we can again define an expectation where we say when the auth middleware gets called, and just as before, we're not calling it ourselves, we're preparing it to be called by using bind here, this as the this keyword, then our dummy request object, then an empty object for response, and then an empty function for the next function. And I expect that to throw. Now, you could check for an exact error message, but if you're not sure, or if you only care about whether an error is thrown at all, you can also just check for throw like this without passing any argument to it. So now this should indeed fail. If I now rerun npm test here, I mean it should succeed because indeed we get an error if we pass this in. Because if I check for this not to throw, just to demonstrate this, now it will actually throw as an error here because it expected it to not throw an error, but actually we got an error here, as you can see, because splitting our code essentially failed. So we want to make sure that an error does get thrown here, and that is another test. Now, of course, the more tests we add, the more difficult this output here becomes to read. Right now, it's still easy. We know we're only testing the auth middleware, and there we got 2 tests. But what if we're testing more than just the auth middleware? What if we later also start testing our controllers, which we will? Well, then we might want to find out which of these statements here refer to the auth middleware and which statements refer to our controllers or to which controller. And for that, Mocha actually gives us more than just the it function for defining and organizing our tests. Besides it, there is a describe function. A describe function is there to group your tests, and you can nest as many describe function calls as you want, so you can have multiple describe function calls inside of each other. Describe also takes a title, and that now is not a sentence that reads like an English sentence, but instead like a header for the group you're describing. Like, for example, auth middleware. Now, describe also takes a function as a second argument, and into this function, you pass all your test cases, as these it function calls are called. So now they're inside of this function of describe. And as I mentioned, if you need it, you can also have a describe in a describe. And then in the function of that describe, you could have your test cases. So now we have that organization. And if I now run npm test again, you see that you have this header here now, which makes it easier to find out to which file or to which area of your code, of your app, these tests belong. And that, of course, can be very useful, and therefore from now on we'll use this describe grouping to make our code more readable and easier to understand. Before we actually move on to the controllers, let's now test something more complex here in our isAuth middleware. Thus far, we tested whether we have a valid header and that we get an error if we don't, so if we have no header at all or if it's not splittable. That is all nice, but what about our actual token verification now? How could we test this? How can we make sure that this fails for incorrect tokens? Well, there are a couple of important things to consider. First of all, and now this is really something you have to memorize, you should not test whether the verify function works correctly. You should not test whether this really verifies a token correctly, so whether this really fails for incorrect tokens that were not created with that secret. Why should you not test for that? Because this is not a function or a method owned by you. This is coming from a third-party package, from the JSON Web Token package, and it's the job of the package authors to test their own code and to make sure it works correctly. So you don't want to test external dependencies. You don't want to test if verify works correctly or if it has bugs. Of course it could have, but it's not your job to test this as part of your application. If you want to get involved with the development of this package, you can absolutely do so in that package, but not in your application. So therefore, we're not testing whether verify works correctly. We only want to test if our code behaves correctly when verification fails, for example, or when it succeeds. So when we don't get back an object that has a user ID, for example, which we actually do get back, right? We get back decoded token with the user ID. Well, we only get this if this does not fail. So we don't want to test if verification works correctly. We want to test if our code then behaves correctly, depending on what verify does. This introduces one new problem though. Verify, of course, comes from a third-party package and therefore it does its job. And now if we want to test if our code works correctly, it's easy to test for a failure. We can easily pass in a token that's not verified by this package because we don't actually know which tokens it creates for us. You might remember tokens are these super long strings. We can't guess them. So whatever we pass into our function here will probably fail here in the verification step. And indeed, let's actually start with such a test. It should throw an error if the token cannot be verified. Let's add our function definition here. And now again, let's create a dummy request object for this test. Here I have bearer and then XYZ. And XYZ is the token that will actually be used, and it certainly will be an incorrect token, certainly not a token created by the JWT package. And therefore now, if I expect my auth middleware with my request object, empty response object, and this empty next function, if I expect this to throw, then this test should absolutely succeed. It should pass, because this will throw an error. And indeed it does. Of course, if we wanted to test the opposite, so if we add yet another test where we want to check, well, if this is a valid token, then decoded token, so this object that returns us, should have a user ID. Well, if we test this, it should yield a user ID after decoding the token. If we want to create such a test and we pass in our token, and we hope that this is a valid token, which it certainly is not, well, then we could write our expect function here. And now we just need to make sure the user ID gets added to the request here, right, to the request object we pass in. So now we'll change our code a little bit. We'll call auth middleware manually here now, pass in a request, empty response object, empty next function, but we call it like this. Request now is our dummy request. And we now, after we executed this middleware, we now expect our request object to have a new property, because we add a new property in the middleware, the user ID property, and we expect request user ID to be equal to a certain value, or we expect request to, and that's also something you can test for, to have a property which is named user ID, right? That is something we could expect for a valid token, because if the token is valid, if it is verified, then we make it past this try catch block. Then it just checks again if it really is defined, and yes, we expect it to be defined, and then we do get the user ID from the decoded token and we store it in the request. So expecting that user ID property to exist on the request seems valid. But of course, as you might already guess, if we now run our tests, we'll have a failing test, and that will of course be our last test. It should yield the user ID after decoding the token, but actually what we do get here is simply an error. We get that error because our token is malformed, because it's too short. It's basically not fulfilling the criteria of the JWT verify method, and therefore it's throwing an error. It's throwing an error that the token is malformed. What can we do in such cases? We can, of course, always test if it fails, but we also want to test the success case. because maybe we have scenarios in our application where it's not failing with an error and still the user ID is not getting stored in the request because we simply don't have that code here. Then we would have a bug in our application which we want to detect with tests. And this would not throw an error at any point here. It would later in the controller when we try to get that user ID, but it would not throw an error here. And still we want to detect this error here already. And therefore a test like this one would be super important, because here we test whether we have a user ID stored in the request object after running the middleware. So to find that, we need some way of shutting down that verify method though. We know that this is not a valid token. But for this test, we don't care. We want to test a scenario where we do have a valid token, right? We don't want to test whether verification works correctly. We know that this normally would not be a valid token, but this is not important to us here. We don't care about whether this is valid. We know that verification will work in the actual app. We don't need to test whether this really fails for a random token. Here, we want it to succeed for a random token because we then want to test something totally different. We want to test if our app works correctly for valid tokens, no matter if this really is a valid token here or not. I hope this is clear, because it is an important part of testing that you think about testing this way, that you are fine defining your own scenarios and overwriting certain functionalities to test something else. So how can we now shut down verify and make sure it simply gives us an object with a user ID so that we can pull that user ID from that object? To solve that issue, we have an external dependency with some method. Well, to solve that, we can use mocks or stubs, which means we essentially replace this verify method with a simpler method. Now, how can we do that? Well, first of all, let's import JWT here by requiring JSON Web Token. And what we can do now is in here, we can of course call JWT verify and set this equal to a new function that simply returns an object where we have that user ID field, which is ABC, for example. So what we're doing now is we're overwriting the actual verify method that this package has. We're overwriting it, and the way module imports work in Node.js, if we overwrite it here, this will be the case in the middleware when it runs too, because we have one global package, so to say, which is used here. So we overwrite this with our own function. Now, if I run npm test, our own function gets executed, and that will return a user ID in that object it gives us. And therefore, it will first of all not throw an error, and it also gives us a way of pulling out our user ID. And so now if I run my tests, this will still fail, but now it fails because we expected to have a property user ID, but actually we don't. We only have an object with a get method because we only have this object. We don't have a user ID. And now we can look into our code and see, oh yeah, maybe we should add this code again to make sure we do store that user ID in the request object. And now if we re-execute npm test, we have 4 passing tests. And that is because we actually replaced the built-in verify method. And that is a common way of handling such cases. However, instead of manually overwriting it like this, there is a more elegant way, because this has a huge downside. Which downside does this approach have? It becomes evident if I cut this test we just wrote and I put it in front of the test we had before that. This is the test where it should throw an error if we have an invalid token. Please note that before, all tests passed, so we did get an error for an invalid token. Here, however, we're then overwriting verify to basically never throw an error. So now after I switch the order of tests, I actually have a problem with my last test because this does not throw an error anymore. Why? Because in this test, I globally replaced the verify method here. That, of course, is not ideal. It's good for this test to succeed, but it means, of course, that if I have any other test that needs the original verify method, it now has no chance of getting that because we replaced it here. And therefore, instead of manually stubbing or mocking functionalities and replacing them, it's good to use packages that also allow you to restore the original setup. For that, we'll install that extra package, which I mentioned earlier already, with npm install --save dev, and its name is Signin. Signin is a package that allows us to create a so-called stub, which is a replacement for the original function, where we can easily restore the original function though. To use that, we simply import signin by requiring, well, signin here at the top of our testing file where we need it. And then in the place where I want to replace verify, instead of manually replacing it like this, I call signin stub, and I pass in the object where I have the method I want to replace, that is JWT. And of course, the official signin docs are the place to learn all about this package and all the different ways of using it. So here for stub, I pass in the object which has the method I want to replace, and then as a string, the method name. Right? Okay, so I have two arguments here. JWT is the object that has the method, verify is the actual method. Now signin will replace that, and by default it replaces it with an empty function that doesn't do anything special, though that's not entirely true. It actually will do things like registering function calls and so on, so that you can also test for things like, has this function be called, no matter what it executes. So now as a next step, with that being stubbed, we can actually reach out to JWT verify, which now is a stub, and there we can call returns. And this is now a method that was added by signin. So now verify is in the end an object, you could say, that can also be executed, but that also can be configured. And returns allows us to configure what this function should return. And here it should return a JavaScript object with a user ID key, which could be ABC. Now, whenever we call JWT verify, we'll actually call that stub. And the great thing is, after checking our expectation here, we can now call JWT verify restore. And this will now restore the original function. That's the big difference to our own stub, where we replaced this on our own. Because now if I run npm test again, all tests pass again, because I actually restore the original function after this test where I needed a different behavior. And now just for completeness sake, of course, we can now also test if request has a property user ID with a certain value. That's an optional second argument you can pass to that property method. So we want to make sure that the value is ABC. Of course, that's kind of a redundant test because we defined the value here. So of course it is that value, but it could rule out that we, for example, manipulated this here and added user ID here in front of this to concatenate a string, because now this would fail and we would detect bugs like that. And it would only succeed if I get rid of that and really store the raw user ID. Now everything passes. So that is something. And as I mentioned, this stub also registers things like function calls. So if you want to find out if this has been called at all, so if the verify method has been called, you can call expect JWT verify called to be true, for example. Now if you run this, it succeeds because the verify method has been called in our auth middleware. And if we now, for example, comment this out and we set decoded token to just an object where we have a user ID, well, then our other tests would normally still succeed. But we do actually get an error here because we expected false to be true. Well, we expect that because now this check here, whether verify has been called, gives us false, but we expect it to be true. But indeed, it has never been called, so now we could fix such an error here. Of course, that was a made-up example, but it is easy to imagine scenarios where you have code, where you change something, and suddenly you have an extra if check, which has a tiny bug, and some method that should be called doesn't get called anymore because you don't make it into that if check. Well, this allows you, so this here allows you to detect such cases. So this is how you use stubs. You can replace built-in methods with empty methods in case you don't care about the return value and what they do, or you define what they should return, and you can then find out whether they have been called. You can use that return value you set up. So you have a very powerful way of replacing some external methods and still restore everything once you're done, so that other tests that might need the original functionality still work correctly. Now, of course, there is more we could test on our auth middleware, but I'd say we tested it quite extensively thus far. And therefore, I want to move on, to our controllers, which of course also house a lot of our core logic. There we have that auth controller, obviously, and we have that feed controller. Now, for that feed controller, we have routes where we need to be authenticated. If we have a look at our routes here, for getting posts, for example, we need to be authenticated. For creating posts, we need to be authenticated. Essentially, for all our post-related routes, we need to be authenticated. And before we take care about that, let's have a look at our auth controller, therefore, because these routes don't require us to be authenticated. Though, does it really matter too much is the question. Well, let's have a look at how we reach our controller functions here, like sign up or log in. We, of course, reach them through our routes, which are defined in the routes folder, where we send requests to in the end. So these are the API endpoints we're exposing here. And now, what did I mention earlier? What are we testing? Well, we are writing unit tests. We are testing units in our code, just as the middleware, the auth middleware. And therefore, what we'll not test is the routing here. We'll not test whether we can send a request to log in and we execute the login function in the auth controller. Because that entire forwarding of the request, the execution of this method here, that is all handled by Express. And as I mentioned earlier, you don't want to test other libraries. You want to test your own code. So we absolutely don't need to test this flow. And therefore, we'll just test these controller functions we export here, like the sign up or the login function. These are the things we want to test. Now in there of course, again, is a broad variety of things we can test. We can test whether we're able to extract the email and password from the incoming request, though that's a test that's not too useful because we will simulate the request that's coming in, so we decide whether that is set or not. But we can then test if it behaves correctly if no email is set, for example, or if we already have a user with that email. However, there is one new complexity added now. We have a database now. We're interacting with the user model here, and the user model, of course, is based on our Mongoose models here. That's our user model, and that behind the scenes uses MongoDB. And that, of course, brings one important question into the focus. How can we test our database? How can we handle this now? And turns out there are two main strategies we can follow. So let's have a look at both. Strategy number one for testing code that involves database operations is that we stub or mock the parts that actually rely on database access. And what would this mean? This could mean, for example, that here, when we execute find one, we again create a stub that returns a predefined result, and we then test if our code behaves correctly. So, for example, we might be interested here in finding out how our code behaves when find one throws an error, so if we're having trouble interacting with the database, or how our code behaves if we don't have a user with that email address when logging in. These are two different scenarios, and we can write two different tests for that. Both scenarios should actually throw an error eventually. Here we throw one manually, and if find one fails, it also will throw an error. But the status code, for example, should be different. The status code should be 500 if the database fails, because we use our default code then, or we set our own 401 code if we have no user. Now to test this, I'll first of all create a new file in the test folder, and I will name this auth-controller.js. And in there, just as in the auth middleware file, I'll import expect from chai. And I'll also import sign-in because I will start with stubbing that post find one method. That of course, that user find one method. Therefore, I will also import the user by requiring it from the user model file, just as I'm doing it here in the auth controller. There, we are also importing the user model. So now I want to test the login function, and since I want to test that function, we need to import this here as well. Or in general, I'll import my auth controller by requiring it from the auth file in the controllers folder. Now let's add a describe block maybe, where we test our auth controller login process, because even if we're only testing the auth controller in this entire file, we might be testing different parts of that controller, like login, sign up, and so on. So here I'll start with login. And then here, I want to start by stubbing my find one method, because that is the first tactic we can apply. We can simply stub that away so that we don't make a real database access. So here, what we can do is, of course, I can again use sign-in, create a stub, create that on the user object for the find one method. Now, if I want to force this to throw an error, I can then call user find one throws. Now here, this will throw an error. Now, by the way, of course, one issue I have here is that I'm in the describe block. This should go into an it block though, so into an actual test case. So here, it should throw an error if accessing the database fails, for example. So now here in that function, we define our actual test code, and there we set up that stub. And the important thing here, of course, is I'm faking that database fail because I completely replaced the find one method with a stub that will throw an error. Because the actual thing I wanna check is, of course, that we should throw an error with code 500. So I wanna check whether our default status code down there really gets applied correctly. Now back in the auth controller, in the end, I also want to call restore here, but in between I of course want to define my expectation. And the expectation here is that for my auth controller, the login method, when that gets called, that it actually throws an error. Now for that, let's have a look at the auth controller again, and you should now recognize that we have the async keyword in front of that. It's not a normal function, it's an async function, and that means in the end we use promises in there. You might remember async await is just a more elegant syntax for using promises. So actually we have asynchronous code in here, which is another complexity we'll have to deal with, because the execution of that code will not happen synchronously, and that means that by default our expectation won't work the way you might expect it to work. So we want to check whether that promise we have in there eventually returns an error for this test we're writing here, right? Because we're testing for an error code of 500. Now for that, let's make a tiny adjustment here in our auth controller file. Let's add a return statement here at the end. This will implicitly return the promise we have hidden behind async await in here. We can now change this code, reach out to the auth controller login, and call this. And of course there, just as before, this is a middleware function in Express, and it needs a request object, a response object, and a next key or next function here. The request object should have a body field which has an email and a body field which has a password. And well, then we should fail anyways. So we don't really need to care about what else we're doing in the rest of this code here. So let's create our dummy request object here. And that request object will now have a body field, and that in turn will have an email, test@test.com maybe, and it will have a password, tester, whatever you want. And I passed it into my login method here. I also pass in an empty object for the response, and I also pass in an empty function here for the next method. Now I can add then here, because we return a promise in the login method implicitly, and then should now be executed once this finished. And there, we now want to check for our error status code. So I get my result here, and I'll first of all simply console log the result so that we can have a look into this. And now let me run npm test. Now what we see is, first of all pass, which is strange. But if we scroll up a bit, we see also undefined here. The reason for that is we go back to the auth controller. I do return here, but indeed I return undefined, right? And that is what I overall return as a value of that promise that gets returned here. So what I actually want to return here is my error object, or a bit earlier here, there maybe it's undefined. So in the success case, I return nothing in that promise, which in the end gets returned. Here I return the error. So now if I rerun npm test, now we see that error object being logged up there. This now looks better. This now allows us to change our code a little bit and actually expect result to be n. And now here you can actually pass in error. Chai is able to detect a couple of types of data, and error is one of them. Of course, the official docs are the place to go to learn all about that. Other possible values would be string, object, null, promise, and so on. So here, I expect this to be an error, and I expect result to have a property. So to have property, I expect it to have property of status code, right? Because my error object should have that status code. So I expect to have a property status code, which should be 500. Now if I run npm test, on first look it looks good. Everything passes. But actually, this is a false pass here. It passes because Mocha doesn't wait for this test case to finish, because we actually have async code in there. And by default, it does not wait for that async code to resolve. It executes this code synchronously step by step and does not wait for this promise to resolve, no matter how fast this is. Now, of course, we can tell Mocha to wait. We do this by adding an extra argument in this function we pass to it, and that's the done argument. Now, this is optional, and it is indeed a function which you can call. So Mocha gives you a function here, which you can call once this test case is done. By default, it's done once it executed the code top to bottom, but if you accept this argument, it will actually wait for you to call it, and then you can call it in an asynchronous code snippet. So here now, inside of this then block, here I call done, and I signal that I want Mocha to wait for this code to execute, because before it treats this test case as done. And now if we run npm test again, now it passes again, but now this is actually a valid test. And we can confirm this by changing this expected status code to 401, because now this actually fails, as you can tell. It should throw an error code of 500. And if you scroll up a little bit here, you see you got an error code of 401, of 500, but expected one of 401. That's what we wrote here. And indeed, it now failed. Without done, and you must also remove it as an argument, because if you have it as an argument, Mocha will actually by default check whether you have code that executes asynchronously. So without that argument, without calling it therefore, now if you run this again, all tests pass. So it's really important to pass done and then call it once you are done to make sure that your tests work correctly. So now if I change this back to 500, which is the realistic expectation, now they all pass, and now this really is correct. Now, obviously, we can test way more about our controllers, but that is basically now all about stuff that I already explained to you. You can write different expectations, you can set up different request objects you pass in with different email addresses and passwords, and that allows you to play around and expect different things. But I also mentioned that there is more than one way of dealing with code that accesses a database. The way we deal with it thus far is that we simply stub it away. We create a stub for the find one method and then define what this should do for this test case, and then I restore it. And that is absolutely fine. It prevents the real database access from happening here, and that of course might be what we want because it allows us to run our test faster, and of course important, it also doesn't impact the database because your tests could still write data to the database, and you definitely don't want this to happen in your production database at least. It is, however, a valid setup to use a dedicated testing database. Because whilst of course the downside is that your tests will run a bit longer, the upside is that you have a very realistic testing environment. If you really hit a database and you really write data to that database and you read it from there, you have a bit of more. You don't just have a unit test, you have kind of an integration test because you have a full flow of controller gets executed, model does its job, reaches out to the database, returns data. You have more than just a unit test, but you also have a test under very realistic circumstances. And in some cases, this might be what you want, and it might be easier than stubbing everything and writing a lot of stubbing code. And therefore, let me show you how you could set up a testing environment for MongoDB where you use a dedicated testing database, because that's important. You definitely don't want to use your production database for testing. You don't want to mess with your user's data for testing and accidentally delete it or anything like that. So let's actually create a new test here, still related to the auth controller, before we finish up this module with the feed controller later. So still related to the auth controller. And we had a look at login. Obviously, there's more we could test. But let's now move on to the getUserStatus method here, actually, to the getUserStatus controller action. There, we're finding a user by ID, and therefore we'll need to make sure that our testing database has such a user. And we then just want to make sure that, let's say, we could of course also test that we don't find a user for ID and test for an ID that does not exist. But let's also say we want to test for an ID that does exist. Then we just want to make sure that we actually don't return an error, but that we instead return a response where our user status is set. That could be a test we want to write. So back in the auth controller, I'll add a new test case and give it a description of it should send a response with a valid user status for an existing user, something like that. Now this again will require that done keyword because we'll again run async code in that test case. And now inside of that test case, I want to connect to my testing database. I want to make sure that there is a user in that database, of course, because otherwise I can't retrieve the user. Then I want to retrieve it and I want to make sure that I do actually then, that my controller action does correctly retrieve the user status and add it to a response with a status code of 200, let's say. Now, for that, first of all, we need to connect to the database. And this requires us to import Mongoose. So let's require Mongoose here and set up a connection down there in this test case. And I'll show you a different way of doing this on a per test case basis soon. But for now, let's do it here by calling, whoops, not disconnect, but connect. And now you need your connection string. And for that, you can generally use the same connection string used before in app.js. So this connection string here, you can use that. And actually, of course, you could copy this entire code here even into your auth controller, add it like this. Now I'll just need to adjust some things. I changed that password for that user in the meantime, so I'll paste that in. And now important, the database to which you're connecting, that should be a testing database. So I'll name it test messages here. And that's super important. Don't use the production database. Now, of course, we don't call app listen when we are successful, but instead here, we now can continue setting up our test. And again, I will show you a more elegant way of doing this all in this nested manner later. So here, I now want to define my testing logic. And my testing logic here, of course, is that first of all, I need a dummy user. So I'll create a user with new user. User is already imported. And that user, which gets created here, of course, has to be created as we do it in our user modeler, as we define it here, with the email, a password, a name. Status does not need to be set because there is a default of I am new, for which we then should check later, and posts array. So email, password, name, and posts is what should be set here. Email could be test@test.com. Password can be tester. And this is, of course, no hashed password, but this is also just a testing setup. The name could be test, and the post array can be empty here. And status, again, doesn't have to be set because there is a default defined. Then we call save, and I return this because this will also return a promise, so we can now add another then block. In this function here, we now have the dummy user set up and saved to the database. With that dummy user set up, we can now do our actual testing logic. So if we have a look at our auth controller here, at the auth controller file, so in the controllers folder, we need a request that has a user ID field because we're finding a user by that user ID. And then we alter the response object by calling a status method on it and a JSON method. So we need to pass in a request object that has a user ID and a response object that has a status method and a JSON method, where we then can set some status data. And again, we can, of course, pass our own response object here instead of using the real one to fine-tune it to our needs so that we can easily test this. So I'll create my request object here, first of all, where I have a user ID. And now, of course, that user ID should be the ID of the user we're creating here. Now, to simplify this, we can give this user an ID. You can explicitly set one. And here, that can be a string. Now, the format of the string matters. You can use the one you find attached to this video here, which is a string considered to be a valid ID by MongoDB. So I'll give this user my own ID so that I can pass the user ID here in the requests so that I do really find a user that exists. Of course, we could also test our code for cases where we don't find a user with the wrong ID. But here, I want to get a real user, and I want to test if this response is set up correctly. Right? Because that is what we're testing. We should send a response with a valid user status for an existing user. So this is the request. Now for the response, I will no longer just send an empty object, but instead the response object will need a status method and a JSON method and some place to store that user status and the response status code. So I will have an object here with a status code field of 500, let's say, initially, of a user status of null initially, then a status method, so a function here, where I get a status code, and I then set this status code equal to code, and then I return this here, so that status returns this response object again, so that here I can actually call JSON on this object, because here I'm able to chain these methods. So to be able to do this, I need to return this here. And then I'll add this JSON function here, where I have some data, which I get as an argument. Now, the data, of course, will be here an object where we have a status key, which is the user status. And therefore, here I will then set this user status equal to data.status, because again, the data we're getting will be an object with a status key. So I'm extracting that and storing this here. And therefore, we now have a response object with which we should be able to interact just as we do in the auth controller. Now is the time to actually run our test code and use the auth controller, get user status, add then here, because this still is an async function and therefore it implicitly returns a promise. So here I then need to, of course, pass in my request, response, and then this empty next function. And then in here, in this function which executes once our controller is done, there I can define my expectation. And my expectation is that this response object now has a status code which is equal, so with to be equal, for example, which is equal to 200 and not 500 anymore, because we should set it to 200 here if we succeeded extracting that user. And of course, that the status is extracted correctly, so that our user status field is populated to the default status we have in our user model, which is I am new with an exclamation mark. So this is our default status. Since we don't set a different status here in our dummy user object, we should have that default status, so I expect it to be set. And thereafter, I call done, because this is when I let Mocha finish this up. Now, let's give this a try and let's run npm test. And we have 6 passing tests, including this one here. It took quite long, which is okay. By the way, if this times out, you can define a longer timeout period by going to your scripts and adding --timeout here after Mocha and set this to 5 seconds, for example, with 5,000, because this is in milliseconds. The default is 2,000, and if you're timing out here, set it to 5,000. But now this seemed to work. Let's also have a look at the database now and see if the test database exists and if the dummy user exists there. Let's have a look at our collections here. And now if I have a look at my database, I have a couple of collections. I do have that test messages database, and there I have a users collection, and in there, indeed, I have that dummy user. And now just to really be sure, if I check for a different status and I rerun this, you can quit that process which was still running with Control-C. Now indeed, we get a timeout error here because we got one failing test where we have that test up there failing. However, it fails for a different reason if you watch closely. You see it fails because we have a duplicate key issue. And that, of course, stems from our setup code here, where I create a new user that now, for the second test run, already exists. And there also is a different issue. This process doesn't quit as it did before. We manually have to do this with Control-C. Now let's fix all these things in the next lectures. Now, first of all, why do I need to quit this process with Control-C? The reason for this is that despite me calling done, Mocha detects that there is still some open process in the event loop. And indeed there is. Our database connection which we open, but never close. So one thing we should do here is when we're done with our expectations, we might want to call Mongoose disconnect. And only when this is done, so here in the then callback, we call done. Now this is the first important step, but right now this wouldn't work because we actually have an overall error in our test case. Therefore, we don't even make it into this then block here. Instead, our setup right here already fails and throws an error because of that duplicate key. Because we're hard coding an ID here, and we already have a user with that ID in the database, and the ID has to be unique, and therefore MongoDB complains when we create it again. The solution is to clean up once we're done. So besides disconnecting, before we actually disconnect, I want to call user, delete many, and pass in an empty object, which means all users are deleted. And that is generally not the worst idea. If you have a test where you set up dummy data, clean up everything after that test so that you can be sure that you have a clean setup for the next test thereafter, and also for the next test run, which is the issue here. Here, for our second test run, we have no clean setup because we already have that user. Now with delete many, we clean that up. There, we now have that then block, and there I then want to disconnect, and in the then block there, I then want to use done. Of course, we can clean this up a little bit by converting this to one promise chain, and we can even convert this to one promise chain. But anyways, the code isn't super pretty, and we'll fix this soon. But for now, the result should at least be that if we run this again, well, it still fails because we still have that issue initially. So let me actually go there and manually delete this user. And now if I run this again, obviously it will succeed, but now also for subsequent runs, it should work. So now this fails because I have one extra exclamation mark here. So let me now convert this back to the valid validation here. Let's now rerun this test here, and of course refresh here and clean up this user one more time so that we have one clean run. Now if we run npm test, now they all pass and this process finishes. But of course this is not perfect, as you can tell. Whenever a test fails, we don't make it into this cleanup phase here because that will throw an error, and therefore we would have to add a catchphrase overall. So we don't make it into this cleanup part here if an expectation fails. And in general, this is pretty clunky and pretty hard to read code. And if we have another test that requires a MongoDB database or our dummy setup, well, then we have to repeat all that code. And therefore, there is a cleaner solution to all of that. That cleaner solution comes in the form of lifecycle hooks provided by Mocha. We have describe and it are our test cases. Describe allows us to group them. Inside of describe, we have certain extra functions we can call that actually will run before all tests or before each test, and the same for after and after each. And what do I mean with that? Well, let's say connecting to the database and creating one dummy user is something we want to do when our tests run. Not before every test, so we don't want to reconnect and recreate a user before every test, but initially when our test run starts. So essentially I want to run this code here, you could say, and I will cut it, before every test. This can be achieved by adding before here. Before takes a function, and if you execute async code in there, you should add a done argument here as well. And then you paste in your async code. And once you're done here, and of course that could be synchronous code too. Here it just happens to be asynchronous because we interact with the database. Once you're done, you call done, and then Mocha knows you're done with your initialization, and it will start running your test cases. So it runs all your test cases after before. And before only executes once, not before every test case, but before all test cases. So now your test cases run, and therefore here we don't need that extra then nesting here. This is not required. And now here, in this bottommost test case, we only define our testing logic. We don't have that initialization work. The same for the cleanup, of course. Clearing our users and disconnecting is not something I want to do here. Here I just want to have my expectations and call done. So instead, inside of that describe block where we had before, where we set up that database connection and add our dummy user, inside of that describe block, we can also add after. And the position doesn't matter. You could define this up there too. After will simply run after all your test cases. Now, just as before, this gets a function, which is also capable of running async code with the done argument. And then you execute your synchronous or async code. If it's async, you must not forget to call done once you're done. And here I do then delete my users and then disconnect, and then I'm done. And now we have that cleanup and setup work in a more centralized place. And therefore, all our test cases can take advantage of that setup. Of course, if you have test cases that need a different setup, you would need to add them in a different describe function. By the way, here login is no longer fitting since we're also testing the user status. So I'll just have auth controller. But you could have multiple describe blocks if you need different hooks for different test cases. Here, all test cases are fine with using the same setup, and therefore they all have the same hooks in their describe block. And now with that, if I run npm test again, we should have the same functionality as before with our tests passing, but now we have a cleaner setup where we also have our guaranteed setup and cleanup hooks, and we don't need to mix this into our test cases. And that, of course, is a way better setup. Now, besides before and after, there also are before each and after each. Now, the difference is that before each is initialization work that runs before every test case. Before runs before all test case, so it's not repeated, it only runs once per test run. Before each is repeated and runs more often per test run, it basically runs before every it function call. This therefore is useful if you need to reset something before every test case, or if you want to have some initialization work that absolutely has to run before every test case. And there also is after each in case there is some functionality which you need to run after every test case. So some cleanup work which needs to be done after every test case. So these also are very useful hooks for testing, of course. To really use a database, it just should be a dedicated testing database. Now, of course, it's also fine to use stubs, as we did here, in case you don't really need or want that database access, in case you want to speed up your tests, you can stub functionalities. And of course, we could have done that down there too, but I want to show both, and both is fine. Now, obviously, as always in the internet, you'll find people arguing strongly for either of the two directions, but in practice, you find good arguments for both alternatives, and therefore you should go with the one you prefer, and you can even change it on a per test basis, depending on a test needs to be faster or really doesn't care about the database access, or if checking that database code might be useful too, like for our status here, where we implicitly also check that our default status assignment works, because we're checking for that default status defined here in the model. Now, with that, let me wrap this module up by also testing some functionality from the feed controller. And here the interesting part, of course, is that here we actually have code that relies on the user being authenticated, like for creating a post. Here, when we create a post, we actually do access the user ID, which should be part of the request object. Now, why is the user ID part of the request object? Because of the auth middleware, right? Here, we add that. So how can we now test this, since we now have a controller that actually requires on the auth middleware doing its job? How can we make this work if we only want to test the controller and not the full flow? It's super easy to make this work, because whilst it could look difficult at first, it's important that you configure your tests. You pass in a request response object and the next function. And if you have code that tries to get something out of the request object, like the user ID, of course in the real app that is set by the middleware, and we are actually testing this middleware. But for the controller, we can just fake that, and we can pass in a request object that simply has a user ID, and we're done. That's all. So let's now write a test for create post, and let's interact with the database here, and then also make sure we do create a post successfully here. And for example, validate that this post then really was added to our users posts array. For this, I'll add a new file here in the test folder, and I'll name it feedcontroller.js. And I'll have a look at the auth controller, and actually I will copy the entire content from there and add it in the feed controller, and now of course change some things. I need access to Mongoose and so on though, because here again I want to connect to a testing database. So in here, I will not need the user model though, but the post model. So let's get that from models post. And of course not the auth controller, but the feed controller, which I get from controllers feed. Now I'll therefore describe this as the feed controller. Doesn't hurt, I guess. And now, time for the initialization work. We're connecting to the testing database. Could also be a different one here for the post if we want to, but I want to use the same one. I will actually set up my dummy user because I need a user. A user created a post, and this should be my dummy user. And we could set up some dummy posts, especially when we're testing different controller actions like getting posts and so on. But for creating a post, of course, I don't need one. So my dummy user is all I need. So the test setup here is fine for me. I don't need before each and after each, but I only need one test case here. So I'll actually get rid of the other one. I'll keep the after hook here though, and clean my users so that other tests are not affected by it, other test files are not affected by it, and this test file here really works standalone on its own. So now let's work on that single test. And there, I want to test whether a post is created successfully and then add it to the posts array of my user, the user who created it. So it should add a created post to the posts of the creator. Something like this. Now, I'll not stop here. Instead, I really want to interact with the database. So no need to use sign in here and stop anything. And if we have a look at that feed controller, we now see that we need a couple of things on the request object. On the request object, for example, we need a file object. That in turn needs a path, which is the path to the image. Doesn't have to be a real path, just needs to be there so that we can extract it. Can be a dummy string though. We need a title, we need a content, because we're setting this on our post. And we need that user ID. So back in the in the feed controller file here where I configure my request, as we saw, we're retrieving title and content from the body. Then we have a file object which has a path key, and we have a user ID. So in the feed controller, in the body here, we have title, which could be test post, with the content, a test post. Really doesn't matter, of course, unless you're testing it. We need a file object, which needs a path key, which can be ABC, doesn't matter. And we need the user ID, which can be XYZ. We just need these fields because we're using them in the controller. This will then save a valid post to the database and will then extract the user with the user ID. And now here we already have the first trap we could run into. The user ID does actually matter because the creator we assign here does not matter, but to really work later and to be connected to the user object in the database, we need a real user ID. Thankfully, we got one. We're creating a user with our own hard-coded ID here, so let's use that instead of XYZ and pass that in. So now the feed controller should be able to save a post and then make the connection to a user and add that post to that user object. Now to check whether that really worked, I need to get access to our user object outside of this controller function. And for this, we can just store the result of user save here in a saved user constant and actually return that here in that controller. Will not change the behavior of the controller. We still send a response status code and everything. That still works fine. But now our test has a look of validating that created user. And now in the feed controller here, we're not calling off controller login or anything like that. Instead, we're calling feed controller create post. We pass in our request object. Now, for the response object, we need to make sure that we don't get an error. So we need to provide a status method and a JSON method, even if we don't care about what they do, but we need them. So I pass in a dummy response object here too, which is an object which needs these two methods so that they can be called without throwing an error. So status is a function that does nothing, and JSON is a function that does nothing here. Why are they not doing anything? Because for this test, I don't care. So I pass in this, and I pass in this dummy next function here. Now this is an async function. We have the async keyword here, and therefore it returns a promise automatically. And hence in the then block here, I want to define my expectations. Now, I know that we get something back here because I'm returning that saved user. Now, by the way, if you're not liking this pattern of changing the controller just so that we can test this, of course, the alternative would be to simply test some other controller action that actually needs that user object with its post, and then you simply call create post, and then that other controller action too, and execute two controller actions in the same test, and only test something on the result of the second action. But here I'll just speed this up and merge this into one controller action. So here I get my saved user, and I expect that saved user to have a property of posts that should be set. And I expect saved user posts to have a length of 1, because there should be one new post added to it, and thereafter we call done. Now let's give this a try. Let's run npm test here. This will now take a while because of course we have a couple of different tests. And of course I get an error here because I have an issue in my testing file. I'm importing the post model, but this of course was incorrect. I'm actually not using the post model here. I needed the feed controller, but regarding the models, we still need the user controller, of course, because I'm creating a user. So that's my mistake here. Let's quit that process and rerun npm test thereafter, so that now we don't have an error here in the testing file. And now here I'm getting an error. Target cannot be null or undefined. And that is stemming from our validation here in the feed controller, as you can see, and we only have one test case in there, so it's this test case. So saved user seems to be null or undefined, even though I'm trying to return it here where I store my saved user. And that actually still is an issue with my testing setup. I do define my response object with status and JSON functions. Now, the tiny problem I have, if we watch closely, of course we're calling the JSON method here, not on the response object, but on the result of the status method call. So for that to work back in the feed controller, we need to make sure that in this function here, for status, which we call first, we return this, so that we return another reference at the entire object, which then has this JSON function here. So now with this adjustment, let's run npm test again. Let's see if we now succeed. And this looks better. It's now passing here 2 for the feed controller. And if I would check for a length of 0 here, for example, then it actually should fail. So if I now let this run, now you see it failed. And if we scroll up, we see it failed. It expected array with a length of 1 to have a length of 0, but got 1. So correctly, it failed. And it doesn't fail if I check for the correct length. Now, this is another example for testing here, the feed controller clearly, as you can see. And now with that, we wrote quite some nice tests here. I hopefully gave you a good introduction to how testing works and how you generally have to think about it. Now let me wrap this up, because I know that at this point, it still can feel entirely overwhelming, and it doesn't have to be. So this is an introduction to testing. You learned how to use Mocha and Chai to write tests and expectations, that you can test async code, that you can work with testing databases or with stubs if you have external dependencies. And still this can be overwhelming, I know, because how are you testing file access? How should you work with sessions or with cookies? There's so much to test. How do you know what to test? How do you come up with good test ideas? Does it make sense to test whether the status code was set correctly, for example? Well, these are all tough questions to answer, or not. Regarding the status code, for example, always ask yourself, are you testing something that you are responsible for with your code? Regarding the status code, of course, we don't need to test whether the status code is set on the response, but if that exact status code you're looking for is correct, that is something you could test. Is it status code 201 or 500? It's you and your code that defines that, so it is something you should test. If you have functions that are very large and you find yourself stubbing a lot of stuff to test some tiny part of it, maybe you can split a function apart. We could do this for our controllers here too. We could, for example, also outsource the part where we add a post to our user posts into a new function that simply accepts a user ID and the created post as an input, and then looks for that user ID and adds that post. So a function that essentially only does this part. We could outsource this into a new function, which then all of a sudden becomes way easier to test because you test functions, and splitting your code into more granular functions can make it easier to maintain and easier to test. So if you have problems testing large functions, try splitting them in smaller, more testable functions. If you're wondering how to test sessions or cookies, well, Google is your friend. Sounds dumb, but it's the case. Search for Node.js Express cookie testing, session testing. You'll find instructions, ideas, thoughts by other people, because testing is a lot about thinking and experience and trying stuff out. There rarely is one correct solution. It's also the case for writing your own test cases here. What do you pass in as a dummy configuration? Like, for example, this dummy request object. How should it look like? Analyze the code you're testing, and then think about how you need to configure your inputs or your dependencies for your test scenario to become real. Of course, always keep an eye open if you're maybe just testing for stuff you're introducing here. For example, when you're testing the user sign up and you pass in some dummy request object with an email and password that might look like this, and you're then expecting a user to be created with the email address of test2@test.com, well, then your test will fail, and not because your code is bad, but because your test is bad, because you define a bad input for your expectations. And therefore, testing really is about trying stuff out, gathering experience, diving into discussions with other developers, diving into Stack Overflow, and that will make it easier over time. I hope it became clear that writing tests in general isn't too hard though, that you write code that tests your code, and the official docs of Chai and Mocha should really help you defining tests, grouping tests, testing different things, and you'll find plenty of third-party packages and plugins that can make it even easier. For example, testing things like sessions or testing promises. There are also packages that make that easier to let you write even leaner code than we are doing here. So with that, I hope this introduction was helpful, and I hope you now are not just able to write awesome Node Express applications, but you're also able to test them both manually and automatically. In this course, you obviously learned a lot about Node and how to write Node code and build web servers or web applications with Node, because that really is its main thing. But Node and NPM, the package manager we get for free when installing Node.js, can also be used as a build tool. So as a tool that runs utility scripts on your computer and can help you with building any mostly JavaScript-driven project. And that does not have to be a web application or a server-side web application if it is one. It could be a front-end web application too, like the React app we had in this course, the front-end for the REST and the GraphQL API. And in this module, we'll briefly dive into that, and I'll explain why that is the case, what exactly NPM is and how we can use it, and how we can use Node as a build tool. It's important to understand that when we install Node.js, we get two tools or two things for the price of one, you could say. We get Node.js and we get NPM, Node's Package Manager. And remember that this was the tool we used for installing packages into our project, or when I share my project, like with all the code attachments, that you could reinstall all dependencies required by that project, even though I did not share the Node modules folder, because we have that package.json file where we see all the dependencies. So Node.js is the programming language we used to execute code, to execute JavaScript code based on that Node.js runtime with all the features that gives us. And especially important when we look at it from a build tool perspective, we have to remember that with Node.js, we were able to interact with files, and this will become important in a second. NPM, as I said, is Node's package manager, so we manage, guess what, packages with it. And with that, I mean we can install packages, download them, manage their versions and so on. And we can also run scripts. We did that with npm start, for example, to start our server so that we don't have to write or type the full command for that. Now let's have a closer look at these two pieces and see what else they can do or how that can be helpful to use them in the context of build tooling, so in the context of utility scripts and not in the context of spinning up a web server. Let's first of all understand NPM a bit better. It's Node's package manager, as you learned, and in the end it's a CLI, a command line interface. We always used it from the command line, from the terminal, by running npm and then some command, mostly npm install in this course. The idea behind packages or tools like npm, and every programming language has a similar concept, you could say, is that we might have some isolated functionality, some code that we wrote or that we came up with that does something useful. Let's say it generates a random number. Now we can use that in our web application, but maybe we want to use it in other applications as well, because this isolated functionality does not depend on our business logic in the project we're creating. Or maybe we want to share it with the public. Well, if we want to share it internally or externally, we can put it into a package with the help of NPM. You can use NPM not just to install packages, but also to create and share packages. Through that NPM repository, which is a cloud service where you don't have to pay for, where you can host packages you created, and this is also the service where you will in the end fetch packages from with the npm install command. So in this repository, which is managed globally, you'll find thousands of packages, obviously. And if you now have some Node project, you can use any of that. You can use any of those packages with the npm install command through that CLI, and that is how you add packages to your project, no matter if that is a package shared by you. And you can also have private repositories or private packages on NPM, by the way. That is something you do have to pay for. But you can always use public packages and share packages with the public. That is the idea behind NPM. Now let's have a closer look at the official NPM repository page and the available commands we can use. You can visit npmjs.com. That is the official page of NPM, and there you can search for packages. For example, we could search for Express here, which is of course a package we used, the Express framework. And then you see all kinds of packages that kind of were found for that, maybe packages that use Express, maybe also of course the Express package itself. And if you click on that, you find some quick docs. You see the versions that were released here. So here you can see the different versions you could install through NPM. You can target a specific version, by the way, by going to your terminal. And there, with the NPM install, you can choose the package and then an @ sign and then a specific version number. For example, we could choose 4.16.3 by typing 4.16.3, and now we would install that version into our project. If we select no version, the latest one is picked by default. That's just a little side note. So we can see that version history, we can see which other packages this package relies on, and these packages will be installed for you automatically when you install Express.js. So these will also end up in Node modules, as will the dependencies of these packages. And that is why you quickly end up with a big Node modules folder, by the way, because you have a lot of dependencies of dependencies of dependencies. You also see other things like the official homepage, the GitHub repository, so the repository where you can find the source code for this package, and so on. So this is really useful. Now, if you want to learn more about the npm command though, so what else you can run besides install, or how you can configure install, for example with --save versus --save dev to install a production or a development dependency. If you want to learn more about that, the official docs are of course the right place. There, if you dive in, you can learn way more about npm, and diving deeply into that would really be beyond the scope of this course, because npm, creating and managing packages, that is a topic on its own, not closely related to Node.js, the language, just an additional feature you get for free. So here you can learn way more about that. And here on this page, if you scroll down a bit further, you also see all available commands you could run. And then if you click on one of them, for example, on install, you also see how you may use it. So here you see detailed instructions on how you may configure it. For example, that you can run it in global mode to install a package on your system and not just in a project, or that you can of course also install it with the --save flag, save dev, or save prod, which is the same as just --save in the end. So there you see all the ways of configuring that or running that command in different ways. And if you want to learn way more about that, and for most cases you just need npm install --save or --save dev or -g. But if you want to learn way more, of course these official docs are the place to go. It is worth pointing out that you also can get help here locally. When you type npm help here, you also get instructions on the available commands you may run, and you can also get help on a specific command. So if I run npm install --help here, or just -h, then I see how I may run this command, and also which options I have to add additional flags. However, these are just the common options, not all options. For the full docs, of course, you should dive into the official documentation here. The commands you can run here, especially installing, are one powerful thing npm allows you to do. You can add any package you want to your project. Another important feature is that if you click on using npm here, you can run scripts with npm. And that in generally is related to that package.json file you get when you put a project under control of npm, which you do with help of the npm init command. We also use that in that course. That will ask you a couple of questions and then give you a package.json file, which you can use to configure a project. And there you can not only keep a list of your dependencies, you can also add certain scripts. And you can run these scripts either with npm start to run the start script, or npm run and then any script name you configured in there. And that is very powerful, especially when it comes to using npm and Node.js to build projects. It is something I can best show in the React application we worked with in this course. Here I am in that application, and there, if we have a look at that package.json file, you see that scripts area, and there you see a couple of scripts which you can run. For example, start with npm start, but that's a special case. All other scripts with npm run, and then for example build or eject. And then these scripts are executed. Now, these scripts actually use a third-party package, so a dependency which was installed, React scripts. We see it here in the dependencies list. And then that dependency holds the code that will actually do something. And that is the next step I will come back to, with Node.js being able to run on your machine and not being limited to spinning up a web server. Now that we briefly walked through NPM and what we use it for, let's bring something back into our memory. Node.js in this course was primarily used to spin up a web server and write code that runs on the server side. And that is indeed the main thing you do with Node.js when you write your own Node.js apps. But we have to remember that theoretically you can run any JavaScript code with Node.js. And specifically, you can also interact with your local file system. You can read and write files after all. And that opens us a new door, a new opportunity. We could use Node.js to execute utility scripts that, for example, parse certain files, manipulate the content, and output the manipulated content back into the original file or into a new file. And that is the idea behind so-called build tools. And that is something Node.js also is capable of being used for. And it's important pointing out here that when we talk about build tooling and build workflows, we mostly talk about front-end web development. Like for example, with our React application here. This React application is not a Node.js app, but still we use a package.json file and we use npm to install packages. These packages are all holding code that runs in the browser though. And in the end, the code we write here in the source folder will also end up in the browser, but let me point out that the way we write it here would not run in browsers, at least not in all browsers. For example, we are splitting our JavaScript code here across multiple files, and we're using ES-module import syntax for merging these files together. Now, this does not natively work in all browsers, only in very modern browsers. And therefore, this is indeed not the code that will end up in the browser. This is the code we work with, but we use a build tool, a build workflow, which is started during development with npm start and for production with npm run build. This build workflow will take our code and kind of merge it together and transform it into code that runs in older browsers too, and that is also minified and optimized. Because that's also important. We use build tools to optimize our code. We might write code that looks like this, and that is indeed how our code looks like in the React app I just showed you. But as I mentioned, this does not run in all browsers, and even if it would be very large. In the browser, since all the code has to be downloaded by your users before it runs, and that's different on the server, there the code sits on the server and that's it. In the browser, the code has to be downloaded, and therefore you want to keep it as small as possible so that your app and your JavaScript code in the browser starts as quickly as possible. Therefore, we want to end up with optimized code. And the idea here is that we also have code that is not only too big, but that is using next-gen features, like here the spread operator or arrow functions. And we want to convert this to code that runs in older browsers too. And that is like an example optimized code, which is shorter. We use less characters, and therefore the code is shorter. And it also does not use next-generation JavaScript features. And that is the idea, and as I mentioned, it's primarily important for front-end development because there not all browsers support the next features, and we want to keep our code as small as possible. That does not really matter that much on the server side. So that is the idea, and that is what we can use Node and npm for. Because if we go back to our React project, we want to convert that code into an optimized version. And if you run npm run build in your project here, you actually start such a production workflow, which means now it's creating an optimized production bundle. And this is all done by npm, which started the script, and by Node. And here it completed. And now indeed, if we look into this build folder, this now holds our app code, so the code we wrote in source, but in an optimized way. There in the static folder, we have JavaScript code. And if we look into that, this in the end is our code, just minified a lot. And therefore it's pretty hard to read, but it's our code. And this code is now just very condensed and only contains current gen JavaScript logic, so logic that runs in older browsers too. This is, of course, not the code we would like to write. It's very hard to dig through that, but it is the code we want to output. And we use npm and Node to transform our code. That's the idea behind build toolings. And now let's have a closer look at how npm and Node can help us with that. So we want to end up with optimized code. And again, this is most important for front-end projects. npm is useful because we can install packages, we can manage this project with our package.json file, and we can of course install packages that run in the browser too. It's our duty as a developer to ensure that we don't try to install Express.js into this project because we couldn't use any functionality from Express.js in the browser. But we know as a front-end developer which packages we can use and we want to use. We find that out with research and so on. And then we can install these packages and we can import them in our files with a slightly different syntax. That just happens to be the primarily used front-end development import-export syntax with that ES module style, because that is actually the style that is supported in modern browsers too. And then this is done by npm. We install the packages, and now we also want to start a script with npm. Now npm's work is over and Node.js takes over. The React scripts package here, let's look into that. And for that, we can look into our Node modules folder, run npm install in case you don't have that, because that will install all dependencies that are listed in your package.json file. And now in Node modules, let's search for that React scripts package. And you can see by the list that is very long that all packages have a lot of dependencies, which in turn have dependencies, which is why we end up with a lot of packages being installed here. Now I'm in the React area though, and there I find React scripts. Now, there we also have a package.json file, because if you share a package, you also need that. You need to add some extra information to the package.json file then, and you can learn all about creating and sharing packages in the official npm docs if you're interested. And there you will also find like the entry point that is executed, which is in the bin folder, the React scripts.js code here. This is in the end the code that will be executed. And now here's something important. This code will in the end be executed by Node.js, because the idea behind build workflows is of course that it runs on your computer before you deploy your optimized code. So before you upload your optimized code to some server. So this code will not run in the browser or anything like that. This code will run on your local machine, and therefore it will be executed by Node.js. This is also the case because in the end this code will kickstart other scripts, will kickstart other code, and it will kickstart code that will also work with your local file system. For example, in the scripts folder, we find the build.js file, and there we will see what else it does. And now this is actually very complex build workflow. In the end, this uses a tool called Webpack, which is used heavily in front-end development to orchestrate your build workflow and to compile your different files and unlock next-gen features and make sure that you can handle the features correctly, again, by using also some other tools like Babel. But that would lead too far here. The idea is here, we are using Node.js. We can also tell that we are by the fact that we now have a different import-export syntax. And we are loading different packages here, we're running them, and some of these packages will in the end also pick up our files, so our local source code we have written here in the source folder, will parse them, and will transform the content in there, pull all of them together, because we don't want to have multiple files in the end, but only very few files with one main file. We'll pull all that code together and then also rewrite our code in a way that also runs in older browsers. And this is all done by a couple of packages which are used behind the scenes here, which are installed by npm, and then the code in that packages is executed through Node.js. And there was a lot of talking about that, but I really want to get that into your heads because it's so important that you understand that you can use Node.js to execute any JavaScript code, which uses Node.js features, of course, on your machine, and that it's therefore also used to run utility scripts, and you could also write your own utility script that like calculates your taxes. But here, the utility scripts actually take our source code and then transform it as defined by the packages we use, because we don't want to write all that build tooling code on our own. And that is another important area where you can use Node.js. And if you want to dive into that area, actually, a lot of the knowledge you learned in this course, like for example, when it comes to working with files, will be useful, but you'll also have to pick up new skills because you need to know all the ins and outs about working with files, managing large chunks of data efficiently, and so on. You don't need to create web servers or anything like that here. You don't need to validate user input. And that, of course, was the main topic of this course. But this is a different area of Node.js that you can also dive into if you are interested. And especially NPM is something that is worth having a look at the commands you got there so that you thoroughly understand what you can use NPM for. And if you want to learn how to distribute your own packages, for example, the Getting Started guide there also teaches you that, how to publish and update packages and so on. So check these resources out. If that's interesting to you, I found it important to mention that this also exists and is an important area where Node.js and NPM are being used. to literally. What you learn in